Okay, cool guys. So what we're going to talk about is something called transformations. And what this is being able to take any of your parent functions that you're going to learn over the next couple years and move them. So instead of them being sort of at the origin, they're going to get to move left, right, up, down. They may get thinner, fatter, stretch, flip, whatever you want to call it. And this is sort of a guideline for you to be able to do it. Now, I want to start with this function, right? The absolute value of x, because you know what this looks like, or you know what the parent looks like. And it'll be the easiest to sort of explain what happens. So I think what I'm going to do, I'm going to go ahead and graph the parent function, and absolute value of x, you've already learned, is the graph that sort of looks like a V, right? And the slope is over 1 up 1 over 1 up 1. On this side, it's down 1 over 1, down 1 over 1. But anyways, slope of 1 or negative 1. And this is what it normally looks like. So how do I take this equation and do stuff to it to make things move around? Okay, well, here's what can happen. All right, so this is going to look intimidating at first, but I promise I will explain it all clearly. So f of x, or remember that just means y, so my equation is y equals, okay, I could have a negative, I could have a number in front of the absolute value bars. I could have an x minus, plus or minus a number in here, and I could have a plus or minus on the outside as well. So this right here, when you see it and you're like, oh my gosh, what is this? Okay, so what you need to look for is the fact that our parent function is the absolute value of x, and any one of these other numbers that's in black here could be a part of the problem, and if they are, they all do a specific job. So we're just going to take some notes on what these things do. Now here's the deal. If there's a negative in the front, okay, if there's a negative, what that's going to do is it's going to flip the graph across the x-axis. So it's going to flip over the x-axis. And the professional, or not professional, but the technical term for that is going to be, what do we call that? A vertical reflection. Vertical reflection. And we use the word vertical because we're flipping it upside down. So if you imagine it flipping over the x, it does. It turns upside down. Okay, so it's a vertical reflection. It's going this way. So that's if that negative is there. Now, if there's a number on the front that's like a multiplier, right, that's being multiplied to the front of the bars, you don't actually distribute it in, guys. Do not distribute it in. This number is going to be, it's going to change your slope. So it's either going to make the graph skinnier or wider, okay? And so the way you're going to know that is if this number is bigger than 1, the graph is going to do what's called a vertical stretch. But what that means in sort of layman's terms is that it gets skinnier. I know that's not a technical math term, but that's what your eyes will see happening as it slims down, okay? Now, if this number here is a fraction that's between 0 and 1, or a decimal, as long as it's a number between 0 and 1, it's going to get fatter. It's going to be what's called a vertical shrink. And that's when it gets wider or fatter. I'll put wider because that's more PC than fatter. Okay, so yay, that's what's going to happen there. We'll do examples of these in a second. Right now we're just taking notes. Okay, the next one is what if there's a number on the inside? So if there's a number that's being added or subtracted to the back, this is going to be your left or right. So if it's a minus, it's going to go to the right. And if you see a plus sign, it's going to go to the left. And I know this is kind of backwards from what your brain wants to do, because that's the exact opposite way of what we think of when we think of the x-axis. But trust me on this, this is how it works. It's going to go the opposite way. So a minus indicates moving right, a plus indicates moving left. And then the last thing is the k at the back. Now, if there's a number being added or subtracted to the back, that's going to be up and down. And that is what you think it's probably going to be. If you see a plus sign, it's going to go up. If you see a minus sign, it's going to go down. So these are all things that you probably have noticed when you've looked at equations on the calculator or whatever. But now it's formally written. So, and I say formally, it's kind of messy, but hopefully you understand these notes. So now let's talk through some examples so you know what I'm talking about. All right, example 1. What if I were to give you f of x equals negative x plus 1 minus 3? Okay, so when you look at an equation, no matter how many things are going on, I want you to read it left to right. Okay, so start on the left and go across, and we want to do things in the order that we see. So in other words, there is a negative in the front. So when I go to talk about transformations, what I'm going to say is I'm basically going to start with, well, there's a negative, so I know I need to flip it. The next thing that I notice is the plus 1. Now, since it's on the inside, if you look back at your notes, a plus on the inside indicates that it's going to move left however many units are behind it, right? So left 1 unit. And then the last thing is there's a number on the outside and it's being subtracted. So it's going to be my down 3. So this equation, as complicated as it looks, guys, you don't need a calculator to graph it. What you need to do is start with the parent, which I should have probably said that in the beginning, but what is the parent function? Well, the parent is the absolute value of x. So you start with the parent function. So I'm going to start by drawing that graph that we talked about earlier. That is, it's got a slope of 1, 1, 2, 2, 3, 3, 1, 1, 2, 2. There we go, something like that. And now I'm going to do this stuff to it. Okay. Now I'm going to use different colors so you can see what I'm talking about. But basically, in green, since I wrote this in green, let me do that first. So I'm going to first flip it across the x-axis. So instead of going up, this is going to flip down. So it's just like, it's a reflection, guys. It's a mirror image going the other way. So this is my step 1, is a flip across the x-axis. Now step 2, I'm going to move and do this in blue. I need to take this and move left 1 unit. Now don't take the old graph, take the one you've already flipped and move it left 1. So I like to start with the vertex because that's an important point, and I move the vertex left 1, and then you can take these other points and move them left 1. And it looks something like, something like that. Okay, so I've just picked it up and kind of shifted it left 1. And now, well, I'm not finished yet. What's the last thing? I now need to go down 3 units. So I'm going to take the blue graph and move it down 3. 1, 2, 3. And then redraw that same fella right there. Yay! So after all is said and done, this final graph that was my last step, this is what it would look like. And if you were to go and type this in on the calculator, you would see that I have done this correctly. So we'll work more with dilations together because they are tricky, but hopefully that kind of gets you a good start as to how this needs to be done. Thank you!